All right, so going through this worksheet, remember to get rid of the absolute value. You replace it with a plus or minus. And then that means it's two different equations, one with a plus and then one with the minus. So now solving for each one, add the 9. R equals 6. I can distribute the negative, or I can divide by the negative. Add the 9. So R equals -3. So these are our values. Now before we do the plus or minus, it's usually helpful to isolate the absolute value. Now you don't have to, but it's usually helpful. You do the best you can, basically. So I can subtract the 1. Divide by the 10. And then now I get the plus or the minus. So -6 plus 9p equals 3. And then -6 plus 9p equals 3. So add the 6. And then p equals 1. And then divide by the negative. Add the 6. Divide by the 9. So if I reduce it, you get 1/3. Now looking at number 4, it's okay that we have an absolute value equaling an x. Remember, if we get rid of the absolute value by its definition, it becomes solvable. So don't let that confuse you. So getting rid of the absolute value. And so now you have the positive, and then you have the negative. So subtract 1, or subtract the x, add the 1. So you get x equals 2. And then now distribute the negative. So subtract the 1, subtract the x. So you get -x equals 0, so therefore x equals 0. Now, we're going to talk about this a little bit more in class, but there is something called extraneous solutions. We need to check our answers. So if I plug this in, we just need to make sure it works. So I get 4 minus 1, absolute value of that, does that equal 2 plus 1? So that's 3 equals 3. Okay, that works. And then plugging in 0, the absolute value of 0 minus 1 equals 0 plus 1. You get 1 equals 1. That also works. For number 6, it says prove that if two absolute value functions equal each other, then this is true or this is true. And so you're going to use that to solve the equation. So that means it's saying that you pretend they don't have the absolute value around them, and then you pretend one has a negative. It's kind of like the same thing with the plus or minus. It's just that you get plus g of x and minus g of x. You can also think of it as f of x equals plus or minus g of x, type of a thing. So the positive equal the positive, you can solve for that. And then you have the positive equaling the negative, distribute the negative, and you can solve for that. Still take your values for x and plug them back in. So make sure that you check your answers. It says find the line parallel to the given line which passes through the point. So remember, parallel is the same as your regular slope. So my slope here is 5. So therefore, my parallel slope is also 5. So I can find y minus y1 equals my m times x minus x1. So I get y plus 2 equals 5 times x minus 1. And then the next one, it says find the line perpendicular to the given line which passes through the point. So my slope is going to be perpendicular. So if my original slope is going to be negative 1/2, your perpendicular slope is opposite reciprocal. So change the sign and flip. So change the sign, positive, flip it, it becomes 2. So then creating my line, y minus y1 equals my m times x minus x1. Remember, the standard form of a circle is x minus h squared plus y minus k squared equals r squared. So your hk is your center, and then your r is the radius. So there's my center, my radius is 2, and then this 4, so my h is 4, and my k is negative 3. So x minus 4 squared plus y minus negative 3 squared equals 2 squared, which is 4. So as a reminder, the parent graphs for a cubic looks like that. For absolute value, looks like that. For a radical, looks like that. Remember, the negative in front means that that's a reflection over the x. So that means, it's going to get reflected downward. This is a rational where you have a vertical and horizontal asymptote. And your graph kind of goes around it like that. And this is exponential. It starts at 0, 1 and has a horizontal asymptote at y equals 0.